I'm with Woodard and Curran, and we're going to talk about some of the oil storage and tank programs this afternoon. We're starting with underground storage tanks. And the underground storage tank program is a federal program. In Georgia, it's delegated to the state to operate. The state has adopted by reference all of EPA's underground storage tank regulations and added on a few of their own where it comes to tank registration, release cleanup, and reporting. Above ground storage tanks, where do they fit into what we're talking about? What we're talking about in this session is solely underground storage tanks. EPA does not regulate above ground storage tanks in this program, although they do in the program we'll talk about next, which is oil SPCC, Spill Prevention Control and Countermeasure. In addition to that, the state fire marshal has regulations pertaining to above ground storage tanks that contain regulated combustible or flammable materials, but we're not going to cover those because they're not within the scope of the audit. So if you go to a campus and you're auditing tanks, that sort of thing, oil storage, we're not looking at the fire marshal rules. So first of all, what is an underground storage tank? It seems like it would be a pretty obvious answer, but it's not quite so straightforward. And I'll just read through this definition. But any one or combination of tanks, including underground pipes connected to the tanks, that is used to contain an accumulation of regulated substances and the volume of which, including the volume of the piping, is 10% or more beneath the surface of the ground. So an underground storage tank in this program does not need to be completely buried. Just 10% or more of the tank needs to be underground. So this could be something like a partially buried tank, a bunkered tank. What is a regulated substance? Not everything that's in an underground storage tank is going to be regulated under this program. Only USTs, that's underground storage tanks, containing certain substances are regulated. So first of all, it does not include hazardous waste. I don't think anybody is storing hazardous waste in underground storage tanks, but if you were, it's not regulated in this program. But it regulates petroleum and hazardous substances that are regulated under CERCLA, the Comprehensive Environmental Response, Compensation, and Liability Act. We'll talk a little bit more about different aspects of CERCLA as we go on, but hazardous substances or petroleum. I've been doing a lot of auditing at colleges, campuses, and I have yet to see a UST that contains a hazardous substance. These are more typically what you think of as chemicals. You're typically not going to find that. So usually what we're talking about at a college is a UST containing petroleum, containing diesel, gasoline. Certain types of tanks are specifically pulled out and excluded from these UST regulations. The first are tanks that are used to store heating oil for consumptive use on the premises. And we've got some of these terms highlighted because we're going to detail those a little bit more as we go forward. Septic tanks are not regulated. Surface impoundments, ponds, pits, or lagoons. Stormwater or wastewater collection systems. Flow-through process tanks. USTs, again, holding hazardous waste or mixtures of hazardous waste and other substances. Wastewater treatment tanks. Equipment or machinery containing regulated substances for operational purposes. USTs with a capacity of 110 gallons or less. I've never seen one that small, but if they're out there, they're not regulated. USTs that contain de minimis concentrations of regulated substances, and those that are meant for overflow containment that do not routinely contain product. They're sort of a backup auxiliary emergency tank. All of these are not regulated. Now, this is an important clarification. Heating oil, again, we're talking, and they define heating oil in this regulation as number 1, 2, 4, 5, and 6 heating oil, bunker C, Navy fuel oil, and other fuels such as diesel and kerosene when they're being used as heating oils. Now, heating oil tanks for consumptive use on the premises are not covered under these rules. So when you're looking at a tank to determine where it's regulated, you need to figure this out. Consumptive use also does not specify how the oil is used. And let me give you a couple of examples here. A UST storing diesel for heating and powering an emergency generator is going to be subject to the rules because it's not being used solely as heating oil. It's also powering that emergency generator. A UST storing number 2 fuel oil to power a generator is exempt because it's heating oil. So again, you've got to come back to this definition. Heating oil Anytime it's used for consumptive use on the premises, no matter how it's used, and by heating oils, we're typically talking on a campus number 2 or number 6 oil, not regulated under this program. Diesel, which is not a heating oil, is not regulated under this program if it's used for heating oil. So say you have diesel in a tank and it's fueling a boiler, you're using it for heating. It's a heating oil because it's being used as a heating oil. It's not regulated under these rules. But if you have diesel that's being used to fuel an emergency generator or that's being used for vehicle fueling, it is regulated under this program because it's not a heating oil. Is that somewhat clear? Basically, heating oil fuels are not regulated under this program. Other types of USTs containing, basically what it'll be on your campus is you have a diesel that's connected to an emergency generator, or if you have a UST tank containing diesel for fueling your vehicles, it's going to be in this program. And if you have a gasoline underground storage tank, it'll be in this program. So all of this confusing definitions aside, that's what it boils down to. Now this is an important relationship, is that a UST, if it is regulated under this program, under the federal regulations at 40 CFR Part 280, is not regulated under the Federal Oil Spill Prevention, Control, and Countermeasure Program, which we'll discuss next. It's a separate program. So an underground storage tank is either in one or the other. It's not regulated in both. So typically what you'll have are the heating oil tanks that are exempt from the UST regulations will be covered under SPCC regulations, and vice versa. If you got your diesel tank that's regulated under this program, not going to be covered under the SPCC rules. So UST is in one program or the other. If you have questions, please at any time let me know. All right, notification requirements. So first of all, if you have an underground storage tank that is holding a regulated substance and meets all of the definitions, you have to register it with EPD. You have to do that within 30 days of installation, but prior to filling the tank or putting the tank into operation. You also have to submit an annual notification to EPD by September 1st each year for every UST. And this is an important thing which sometimes folks forget to do. You get that registration and you might tuck it into a file, but it also needs to be posted near your tank facilities. So if you have tanks that are registered, make sure you actually post that current registration somewhere and switch it out each time you get your renewed registration. All right, now getting into some of the regulations and what you have to do with your tanks, what sort of design requirements they need to meet. The regulations that were passed in 1988 specified that by December 22nd, 1998, existing tanks had to come up to spec with the new regulations. So they had 10 years in which if you had an existing tank, it either had to be upgraded to meet the upgrade design requirements, it had to meet the new tank requirements, or it needed to be replaced, removed according to the actual closure requirements and the rules. You had to do one of 3 of these with an existing tank. You know, you see that was 10 years ago, you figure, well, I'm sure that's all been taken care of by now. But it's surprising. You do go out there and you still find tanks that have not been upgraded to meet the design requirements. So don't assume that everything's been taken care of because that deadline is 10 years old. Secondly, if you install a new tank after December 22nd, 1988, when these rules first came into play, it had to meet the new design requirements for tanks. We'll talk about what those are. So the UST requirements. There are three key criteria that a UST system has to meet. It has to have spill prevention and overfill protection, corrosion protection, and release detection. And just like all rules, there's an exception to this. If you have a UST system storing fuel strictly for emergency power generation, and again, this is typically a diesel UST hooked to a generator, it doesn't have to meet the release detection requirement. It only has to meet the first 2, the spill and overfill protection and the corrosion protection. If you have other tanks, again, your fueling tanks, diesel for vehicle or equipment fueling, gasoline tanks, they have to meet all 3 of those requirements. So what do these requirements mean? First of all, the implementation and operational procedures. If you have a UST that's subject to the rules, when you're working with this tank, you have to make sure that the receiving tank has sufficient capacity for the load that's going to be delivered to it. Seems obvious, but they've written into the rules that you need to do that. That's why tanks have gauges, and we check everything before we get a delivery. All oil transfers also have to be monitored continuously. The other piece of the spill and overfill prevention is that USTs have to be equipped with the means to catch any potential spill when the hose is being detached from the fill port area. And that's typically done by means of using a spill bucket or a catchment basin. And here you see a picture of one. Hard to tell exactly what it is, but right here is the actual fill port for the tank where the hose would connect. And then surrounding this is just an extra basin. Because sometimes, again, you detach that hose, you're going to get some drips, a little bit of spillage. Here it's collected inside that basin rather than spilling around the ground all outside the tank area. Most of your fill ports for underground storage tanks are in the ground like this. Occasionally you'll have a raised up pipe that's a fill port, but more likely it's under a plate in the ground. All right, overfill equipment. In addition to having that catchment basin, we want to make sure, because this is the biggest area that people have for releases for oil spills, is overfilling a tank. So there has to be some mechanism in place to help prevent that from happening. And a few of the options are outlined here. First of all is an automatic shutoff that's set to shut off when the tank is no more than 95% full. It will not accept any more flow. You can also have a transfer operator is alerted when the tank is no more than 90% full by restricting the flow and eventually shutting it off. Or I doubt you'll have any of this because you've got a really big tank if you get a notification 30 minutes prior to it being full. But again, these are all just different mechanisms so that as the tank is approaching full, you're notified well enough in advance so you can stop the transfer. And to give you an idea here, what a few of these mechanisms look like. And sorry, I forgot to mention at the beginning, but there's a really, really useful EPA publication called Operating and Maintaining Underground Storage Tank Systems. And if you just Google that or go to EPA's webpage for USTs, you'll find it. And it has a lot of the diagrams that we have in here were actually taken from that publication. So if you haven't worked with tanks a lot and you don't know what some of these terms are and you want to get a really good idea and description of corrosion protection and release detection, and what does it all mean? That's a really good resource. I use it a lot, and I think you'll find it very helpful. And anyway, this is one of the diagrams that came from that, and you can see what an automatic shutoff device is and how it might work. You've got a float inside the tank so that as the product level raises, the float goes up and eventually shuts off the flow of the tank so that you can't have an overfill. Similarly, an electronic overfill alarm, if you have your tank hooked up to an electronic monitoring system, works very similarly. And that again, you've got a float. Here's a product float. As the product in the tank rises, this float comes up and then eventually hits the electronic monitoring device and sounds either a visual, audible alarm, or both. Now, corrosion protection. We don't want tanks to rust because when they rust in the ground, they're going to spill and release their contents. So all tanks that hold the regulated substances need corrosion protection. And there are one of three ways you can do that according to the regulations. Fiberglass reinforced plastic, a steel tank protected with cathodic protection, or a steel fiberglass reinforced plastic composite tank. And we're going to talk about cathodic protection in a minute if you're not sure what that is. The piping also needs to have corrosion protection because if you've got an underground storage tank, you're going to have some amount of underground piping. Unless you've got it running in a vault and it's not in contact with soil, most of the time it is going to be in contact with soil, so there's the potential for corrosion. So similar to tanks, it can be either fiberglass reinforced plastic, steel that's protected with cathodic protection. You can have a corrosion specialist determine that there is no potential for corrosion in your soil, if that's something you want to try to do. I haven't seen anyone actually do that. Or you can design some other means that EPD approves for the corrosion protection of your piping. Cathodic protection, there are two different methods of cathodic protection. There are sacrificial anodes, which is the first one we're going to talk about. And what that is that you attach anodes to the ends of the tanks, and because the anodes are more electronically active, the corrosion is drawn to the anodes rather than the tank. And then the second means of cathodic protection is the impressed current system. What you have here is a rectifier which provides direct current from the anodes right there. And they protect the tank because they overcome the corrosion protecting mechanisms that would act upon the tank from the soil. And instead, you've got that current going to it. It keeps the other corrosion promoting current away from the tank. So this is what you have to have if you have a steel tank. Most tanks, especially if they're relatively new, they're not putting steel tanks in the ground anymore. They're going to put the FRP, the fiberglass reinforced plastic tank in. But you need to find out, if you're auditing, what is the construction of the tank and the piping to determine whether it meets these requirements. There are tracking mechanisms for the cathodic protection system that you have to have in place. It has to be tested within 6 months of installation and every 3 years thereafter, and the results of the last 2 inspections need to be maintained. And if you have the impressed current system, you have to inspect that every 60 days to make sure the equipment is operating properly. That's because that's relying on that rectifier producing that current, and if it ever stops producing that current, the tank is unprotected. And the 3 most recent inspections for that type of system always need to be maintained. And again, if you're auditing underground storage tanks, you're going to be looking for these records and make sure that they're available. Well, if they've got a rectifier, there's actually going to be a panel that you can check that's indicating whether it's working or not. Beyond that, again, they've got the testing records, and that's what you have to rely on, the testing records that say, yes, the system passed. But it brings up another good point, and how do you know what they have? And I was going to talk about this later, but it's kind of a good time to go into it. Sometimes you will go into a facility and they may not know what their tank is constructed of. They may not know when it was installed. They know that when it gets down to this point, they order more fuel oil and it's delivered, and that's all they know about it. And that can be really difficult, because how do you know if a tank has corrosion protection? You know, how do you know when it was installed, so which criteria it's subject to? You may not. And if they don't have any files on it, which I have encountered before, that sort of is the finding, that you can't tell whether this tank is in compliance with the regulations because there's no information on it. There may be other findings associated with it in addition to that, but that certainly is going to be an issue, because you can't tell whether it complies if there's no information. Let's move ahead with this a little bit. We went through cathodic protection. Now release detection. Now what is release detection? New and existing USTs have to be provided with some means of release detection that can detect a release from any portion of the tank and the connective piping that routinely holds product, that is installed, calibrated, operated, and maintained according to the manufacturer's instructions, and that meets the performance standards specified in the regulations. Now remember, there's that one exception, that you've got a diesel fuel underground storage tank for a generator, doesn't need release detection, but any other kind of vehicle fueling UST, if you're using that UST to fuel vehicles or equipment, gasoline or diesel, does need release detection. Now it sounds like all of yours are getting this anyway, and it's certainly a good measure, but it wouldn't necessarily be required if it was for a generator tank. So the various methods of release detection, you have a lot of different things you can choose from, although really only a few of them are commonly used. The different methods are inventory control, manual tank gauging, tank tightness testing, automatic tank gauging, vapor monitoring, groundwater well monitoring, and interstitial space monitoring. Each of these has its own sort of exceptions and criteria that you have to follow if you're using them. Piping release detection, also required in most circumstances. Automatic line leak detectors, you can use line tightness testing, or any of the tank methods. The one exception is that if you have suction piping meeting certain requirements, you don't have to have a release detection system in place for your underground piping. Now, to give you sort of a visual of what some of these different release detection methods look like, start over here. That's a vapor monitoring well. Again, that's just watching for vapors from any released product coming through the soil. Secondary containment, which is what most of your tanks probably have, and this would be a double-walled tank for the most part. You've got your inner tank and then essentially an outer tank, another tank completely surrounding that first tank. And the space in between here is your interstitial space. And that's what you monitor to see if there's any product released in there from the primary tank. Groundwater monitoring well, again, just looking for product being released from the tank that's getting into groundwater. Line leak detector, this is a line running from the dispensing mechanism into the tank, checking for leaks in the piping. Tank tightness testing, pressure tests they can do on the tank to make sure that it is, integrity is intact. And then the good old tank sticking. Take that stick, stick it in the tank, and however many inches are, you convert that to the number of gallons that are in the tank based upon a chart for the tank. So these are the different methods you can use. Most tanks, especially if they're new one, you're going to have electronic monitoring of a double-walled tank. This is a panel. What a panel is an example of what a panel could look like for an electronic monitoring system. Whatever release detection system you use has to be monitored every 30 days, and the record's kept for 1 year. So if most of you have an electronic panel like this for your tanks that are subject to this regulation, you have to test that each month and keep a log of testing it. So this is something I'm wondering about if you've got GFA coming in and hiring people to maintain your tanks and do things like that. They're probably not doing this, so this is something that would probably fall back to the campus, this monthly release detection method, logging. Okay, hazardous substance USTs. Again, does anybody have a hazardous substance UST? Not petroleum, not gasoline, some other chemical. I don't think so, and I don't think you'll encounter it. But if you did have one, it's required to have a double wall. But there is a new rule, effective this past April. And this comes under the Federal Energy Policy Act of 2005. And they sort of got at this through a backdoor way. The federal government didn't issue new regulations that you have to comply with. But what they said is that if your state receives money from the federal government to run its underground storage tank program, you will comply with these new guidelines or you won't get any money. So they didn't make new rules, but they made the states adopt these new guidelines. And Georgia has done that, again, effective April 2008. So if you put in a new UST after this date, you have to have secondary containment and interstitial monitoring for it if you're within 1,000 feet of a community water system or public drinking water supply. I don't think this is a problem because I don't know too many people who are putting in underground storage tanks these days that do not have secondary containment. But now it's actually a requirement if you're anywhere near a drinking water supply system. And when you put in a new tank, you have to prove to EPD that your tank is not within one of these areas if you're not going to put secondary containment around it. And with this system, interstitial space has to be monitored every 30 days. Yes, it does. And again, typically it's a double-walled tank. It could be a tank in a vault or some other means. And in addition to that, under the same rule, and again required as of this past April, under dispenser containment is required for newer replacement fuel dispensers. So if you have a gasoline or a diesel pump, you have to have containment around that dispenser. And you have to take a look at that and inspect that dispenser annually to make sure it's not leaking. And again, that's if you're near any underground sources of drinking water. So suspected release reporting. If you think you might have a leak, even if you haven't proven it, you have to report that. And what some of those scenarios would be, and the reporting time frame is within 24 hours, if there is a release of a regulated substance in UST site or the surrounding area, if the UST is operating strangely and you can't account for how it's operating and it doesn't correct itself in a short period of time, or if your release detection monitoring result indicates that there may have been a release. If you can't disprove any of these, then you need to report it as a potential release. You have to contain and immediately clean up any spill. Kind of an obvious thing, but it's written into the rules that you have to do that. And you have to report any of these spills to EPD within 24 hours. If 25 gallons or more are released into the environment or onto surface water enough to cause a sheen, if the release of the hazardous substance meets or exceeds a reportable quantity under CERCLA, that's a Comprehensive Environmental Response Cleanup and Liability Act, which we'll focus on a little bit more tomorrow, or if the cleanup cannot be accomplished within 24 hours. Again, under any of these conditions, you have to report to EPD within 24 hours. Was there a question? Okay.
Well, I don't want to know the amount, but you got it now, so it's also an answer.
Okay.
25 gallons. If it's less than 25, that you can clean up yourself. You can do that, right? You don't have to report it.
If it has not been released to water. Anytime it gets into water, you have to call all the time. Yeah. But if there's a small amount and it's cleaned up within 24 hours, then you don't have to report Not going to go through any of this in detail, but there are extensive cleanup and corrective actions requirements if you do have a release, if you have a leaking tank. Site investigation has to be done. EPD has additional response in addition to the ones that EPA has implemented. And sometimes you have to have corrective action plans and you have to have professional engineers involved in the whole cleanup operation. Temporary closure, which can go on for some time apparently, is really only meant to be if you're closing a tank for up to 3 months. But if you're doing that, you have to maintain the corrosion protection, release detection equipment and still inspect it, make sure it's working. If you're closing it for 3 months, leave the vent lines functioning, cap and secure all of the other lines. Permanent closure, at least 30 days before closing, have to notify EPD. To close it, remove all of the product and sludges, purge the tank of all of its vapors, and then you either have to remove it from the ground or fill it with an inert material. We're talking about filling it with Portland cement, some other material like that. You don't have to remove it if you fill it with inert material. You have to do a site assessment report and whether there's been any contamination of the ground surrounding the tank or gotten to any groundwater in the area, and the closure report submitted to EPD within 45 days. You know, let me check. I believe it's 3 years, but let me check that for you. I mean, I never would get rid of it. There's usually the regulatory requirement for having a record and then what common sense dictates you want to have. You know, you keep your hazardous waste manifest for 3 years, but frankly, I would not throw them out after 3 years. So this is the kind of thing, yeah, you definitely want to keep forever, regardless of what the requirement is to prove that it was done properly. So, good point. Financial responsibility. The government wants to make sure that if you do have a release from this tank, something goes wrong with it, there's money there to pay for it. Now, as a state agency, you're technically exempt from this. But what you would have to do if you were not is have some sort of financial assurance mechanism in place, which can be a special insurance policy, a bond, or something like that. Or you can buy into the Georgia UST Trust Fund. And that supplies, if you contribute to that, supplies monies for you to help clean up. But again, you're not required to have financial responsibility. A lot of folks do pay into GUST anyway as an added measure. So, underground storage tanks. And what I'm going to do, I'm just going to briefly go through some of the points you want to cover here. Then we're going to, do we have a break after this? Then we'll take a break and we're going to come back and do SPCC. And then after we do SPCC, then I'm going to talk in general about some things you might want to do to prepare yourself for auditing tanks and things like that, because if you're getting tanks, it makes sense you're going to do both of those. If you have the responsibility for auditing, you're going to have underground storage tanks and oil SPCC because they're so closely related. So after we go through the two of those, then we'll talk about some of the practicalities of conducting an audit for those things. But just briefly here to summarize a few points. First of all, you have to figure out whether a facility has any USTs. And I just want to caution you that if you do that pre-audit questionnaire, you get it back and they say, no USTs. You're like, great, I can check that off my list. Be careful, because I have had people tell me that they don't have USTs or they don't have this, they don't have that, and then you get to campus and there it is. So if you haven't prepared, if you thought, well, I really don't need to read those rules, I don't need to brush up because it's not going to apply, all of a sudden you could be caught unawares not knowing what to do. So just be cautious in the information that you rely on from the pre-audit questionnaire, because maybe the person who filled out that question or that piece didn't have all of the answers. So don't automatically think that you don't need to prepare for something that you've been assigned, because you could be surprised. If they do have USTs, when were they installed? Either pre-1988 or post-1988, so you know which rules apply, either the upgrade rules or the new tank rules. Check and look at the tank. I mean, you cannot see much with an underground storage tank. You can see the fill port. Maybe you can see some piping if it comes above ground. You can see monitoring panels. But take a look at what you can see of the tank. Look for any signs of release, any oil staining around the fill port. Check for all of the records that we talked about. Check for the registration. Check for any of the inspection and testing records. Check for the release detection monitoring reports for the monthly checking. Make sure that the tank has, and it sounds like all of yours will have with this whole state program, but make sure it meets all of those requirements. That it has corrosion protection, that it has release detection, that it has the overfill prevention mechanisms in place. make sure that, again, all of these records are in place. Notifications were submitted. They've got tank closure records if they've closed tanks. And we just talked about tank closure. No, because they're considered flow-through wastewater treatment systems. Their point is not to hold oil. They're not meant to be an oil container. So if that's what those are used for, if you've got this flow-through system and it discharges to your sanitary sewer, the oil is collecting over there, the water continues to flow through the system, it's not subject to either of these rules. It may be, and we're getting ahead a little bit for tomorrow, may be subject to some wastewater rules. Your sewer use ordinance may mandate that it be maintained on a certain frequency or that you keep records for maintaining it.